developing a beta ketoenamine cough. You have a robotic platform that will execute the experiments, and all post-synthetics are standardized. Your task is to conduct literature investigation of cough syntheses and develop reaction conditions. Generate a table containing an initial 96 screening conditions most likely to yield highly crystalline coughs. Okay, the prompt continues. Select precursors, stoichiometry. It's telling you, just like I don't even advise students in this detail. Okay, so it's advising the student, it's an agent that's advising the student as to the details and what are the potentially the most important parameters. Then it spits out all kinds of conditions. Most of them not surprising, but some of them are surprising, right? Some of these are not ones that, some of them that we have not used. But anyway, whether they are surprising or not, we have these conditions. We subject them to this experimental cycle where you have a robot that dispenses the solids of the starting material, the solvents. You do the reaction, you put it in an oven to heat it up, you wash it, you do a high throughput PXRD, and then you redeposit your outcome, you deposit your outcome back into ChatGPT. Okay, and in this case, we labeled our data in terms of crystallinity and gave it back the results of that experiment, and we went through this cycle 3 times. And every time, putting the results back in and asking ChatGPT to elaborate. And this is the result. The red indicates crystalline material. Okay? 3 times more crystalline than what's been done in the last 10 years, what's been attempted in the last 10 years. And these 3 cycles took us 2 weeks to do. Okay, so in 2 weeks, we can get crystallinity 3 times the crystallinity that took the community 10 years. The community could not achieve, in other words, we can achieve it in just 2 weeks at 3 times what was the going crystallinity. This is transformative to what we do as chemists, at least in my lab. This is ChatGPT, and it's doing chemistry. It's helping us do chemistry. It's helping us, well, it's an agent helping us to direct our efforts productively. Okay? Why? Because it takes advantage of the facts, the experimental facts that are reported in the literature. It looks at the papers, it looks at the supplementary information, and it takes every word that you tell it very seriously. Okay? Humans don't do that. Okay, and it comes up with stuff that, even if it is just a summary of the literature, it's still very useful because it's making decisions based on facts. We, in my lab and in many chemistry labs, we make decisions based on what's called chemical intuition. Well, chemical intuition is not all based on facts. Okay? Just take, for example, one of your students who says the reaction didn't work and say, okay, well, how many times did you try? They'll say, well, I've tried many times. And you'll say, well, give me the reasons why you think it didn't work. They will very readily give you 12 reasons why something didn't work. And if you go through each one of those reasons, you find that they're not scientifically sound or they have not been proven. So chemical intuition is not good. It's wrong. If I have the facts in front of me, I am liable to make better decisions than the chemical intuition. And that's, at minimum, ChatGPT is doing that. But in this case, it's also learning what works, and for the first time, you're putting back into ChatGPT what doesn't work. And as soon as you do that, this model gets better. It starts doing choices, it starts giving you results better than what people in the lab could do without ChatGPT. So, in my group, the whole group has switched to this system. This kind of work, where they come to my office and they say, Professor, I tried to crystallize a cough and it didn't work. I say, well, have you used this? And the students have a fancy name for this. And if they didn't, then that's basically the whole group is switching to using this method. Why? Because you get results. So I talked about coughs and